All right, so in this video, we're going to look at some of the functional brain systems. Now, this includes networks of neurons that work together, but span pretty wide areas of the brain. So we'll talk about the limbic system versus your reticular formation. The limbic system are a lot of structures you find on the medial aspects of your cerebral hemispheres. And this includes like your fornix, your amygdaloid body, and cingulate gyrus. The fornix is a lot of white matter that's involved with connecting large portions of your limbic system. The amygdaloid body is involved with recognizing angry or fearful facial expressions and assessing danger and eliciting fear responses. And the cingulate gyrus plays a role in expressing emotions through gestures and helps resolve mental conflict. So if you look here, we see there are a lot of different structures that make up your limbic system. For one, we have cerebral structures of the limbic system, things like your cingulate gyrus, some of your septal nuclei, your amygdaloid body, your hippocampus here. The dentate gyrus and parahippocampal gyrus are also nearby. And these are involved with different functions like learning and memory, but they play a role with the limbic system as well, especially the amygdala, because learning and memory can elicit things like memories of a fearful event or memories of a time where danger could have occurred. These would all play a very important role with helping to mediate these emotional responses via the amygdala. You can see that the diencephalon also has some structures here, like your hypothalamus, which is involved with the visceral responses to emotion. Our mammillary bodies, which are a part of your olfactory system, because your olfactory bulbs, they transmit information straight back to structures that not only are involved with kind of conscious perception of odor, but also as part of the limbic system. This is why smells and emotions are very intimately linked. And it also involves fiber tracts like your fornix and anterior commissure. The fornix is here, anterior commissure is over here, which is like the anteriormost part of the corpus callosum. And these are played very important roles with connecting all these brain regions to allow for emotional processing. Now the limbic system interacts with your prefrontal lobes as well, and your prefrontal lobes are involved with kind of like higher order processing, conscious perception of things like morality, personality, judgment, behavior. And so if your limbic system is associated with this, we see that it helps us to make conscious decisions about emotional processing, and it also provides some emotional richness in our lives. We're not just these computers that are aemotional. We actually can apply emotional qualities to our experience that actually enhances our day-to-day experience. The hippocampus also plays a role with emotional memory. So when you think about the times in your life that are very emotional, typically you have the best memory of that. So emotional aspects of your life are stored better because of the association of your amygdala with the hippocampus, which is a learning and memory center of your brain. Now, a different system here is the reticular formation. And it's nearby the limbic system, but it's a completely different system that's involved with basically sending impulses to the cerebral cortex to keep it conscious and alert. We call this the reticular activating system, and you find it extending through the core of your brainstem and your diencephalon. It also helps to filter out repetitive, familiar, or weak stimuli. So for instance, 99% of the stimulus that is transmitted towards your brain and spinal cord actually doesn't even make it to the cortex. This is because your reticular activating system decides what's important and it filters out the rest. So, it's involved with attention in that regard. So it's also something that's inhibited by sleep centers, alcohol, and drugs. So when you're sleeping, your reticular activating system is no longer transmitting information to the cortex. This is why you're no longer conscious of the world around you while you're sleeping. And severe injury can result in permanent unconsciousness or coma. So you can look at the activity of the reticular activating system to determine someone's coma state. So if you look at this, ultimately what we find here is in a cross-section of the brain, we have a lot of ascending inputs, information from your spinal cord, visual information from your retinas. All this ascends up towards the thalamus. And the thalamus, which is part of your reticular activating system, the same with different nuclei in your brainstem. We talked about reticular formation structures in your pons, your medulla oblongata, and your midbrain. And ultimately, this transmits information towards the thalamus, which relays that towards the cortices, whether it's somatosensory cortices or visual cortices. And because the reticular activating system is involved with filtering out information, it plays a very important role with attention. So if you think about how you want to focus on a very specific thing, it's your RAS that would help you with this. And if the RAS is less active, you also don't send information to the cortex, which is going to be important with sleep.